This is Chapter 8, Section 1, Similarities in Right Triangles. Your objectives are to use geometric means to find segment length in right triangles and to apply similarity relationships in right triangles to solve problems. I want you to go ahead and write your essential question and then come back after you've done that. Before I go to the next page, I want to review what a mean is. We had a ratio equal to another ratio, so this is a proportion. A over B equals C over D. A and D were your extremes, and B and C are your means. We're going to talk about that today. So here's your first theorem. It doesn't have a name, but on a test or on a quiz you would just be asked to describe it or tell me what it says. So this one is talking about the altitude to the hypotenuse of a right triangle forming two other triangles that are similar to the original one. So this right here is my altitude. So it goes from the hypotenuse out to your 90-degree angle, and it creates two smaller triangles that we're going to look at more closely. So ABC is similar to ACD and CBD. So our first question is asking us to write a similarity statement comparing the three triangles. And we have this one here. I'm always going to start with my larger one, and I'm going to make my 90-degree corner over here. So I know the largest triangle has W in the 90-degree corner, V in the side directly above that, and then U off to the end there. And then I'm going to make two more triangles, one smaller than the first. These are supposed to be 90-degree triangles. Alright, so the medium triangle, this one here, my 90-degree for that one is going to be in this corner, so that's Z. And then the shorter length above Z is W, so that's supposed to be up here. And the longer length to the left of Z is U, so that goes here. And then the smallest triangle over here in the corner, again at the 90-degree angle, I have Z. The shorter length above Z is V, and the longer length to the left of Z is going to be W. So my similarity statement is going to be that triangle UVW is similar to triangle UWZ, which is going to be similar to triangle WVZ. If you want to check to make sure that you are understanding what you're supposed to be getting from this problem, please go to page 521. Try and work out problem number 3 and check your answer in the back of the book. This is what I was talking to you about earlier when we were discussing that we were going to review means and extremes. We're talking about a geometric mean. A geometric mean basically is when your two means are the same numbers, so it's going to be something squared. When I use cross products with this, I have x times x, which gives me x squared, equal to a times b. And we're going to use this for the next two theorems, or the next three theorems, two theorems that we're going to be learning. So that's this part here, x squared equals a times b. And then if you're solving that, you're going to take the square root of both sides. These are going to cancel each other out, they're inverses, and so I get x equals the square root of AB, which is what this says here. Okay, so basically all you need to know is that x is your geometric mean when it's that same number in the mean spot. To find the geometric mean, we are going to use these two numbers, and I told you earlier that it's x squared equals those two numbers multiplied. Let me bring back that piece of paper real quick. So this is what we had here. X squared was the a times b. So they gave us 4 and 5 as our a and b. And we have x squared times, or is equal to 4 times 25. 4 times 25 is equal to 100. So that means x squared is equal to 100. And then if I take the square root of both sides, I have x being equal to 10. We only want the positive root because we're going to be talking about distance. Again, page 521, problems number 5 and 9, work them out on your own, see if you are understanding what you need to be understanding. So this is the pre-work for our next theorem. We have the largest triangle here, and then the medium or middle triangle is flipped and rewritten here so that it's easier for us to see. And then the smallest triangle, same thing, has been redrawn over here again so it's easier for you to see. And what we did, or what I have here, is the ratios already written up. So b over a is equal to y over h is equal to h over x. So we have the ratios for all three triangles. And then if you'll notice here, you have your geometric mean because I have two of the same number. This one here has c, the hypotenuse, over a, this vertical leg, which is equal to b over h, which is equal to a over x, right there. And then if you notice the c over a and a over x create a geometric mean right here because those two are the same number. And then the very last one, c over b is equal to b over y, which is equal to a over h. And again, geometric means because they're the same number diagonally. And if I use cross products for each one of these, and we're actually going to do that because that's going to help us with the next theorem, h times h is going to give me h squared equal to y times x. A times a is going to give me a squared equal to c times x. And b times b is going to give me b squared equal to c times y. And this is exactly where the next two theorems are going to come from. And I'll show you that right now. So this is exactly what we wrote on the previous page. And the first one is talking about the altitude. So this altitude here. H squared is x times y. These two smaller parts of the hypotenuse. A and b are the legs. That's the second corollary. This one was talking about the hypotenuse. The legs of the triangle. A is going to be the smaller piece of the hypotenuse that's attached to it, so this is a smaller triangle, times the entire hypotenuse. And B, the other leg, is going to be the smaller piece of hypotenuse that's attached to it, times the entire hypotenuse. This is something that you're going to have memorized. So the, oh, this is altitude, I meant to circle. So the altitude is the two hypotenuse pieces multiplied, and each of the legs, so if I'm talking about the smaller leg, it's the smaller piece times the whole thing, and if it's the longer leg, it's the longer piece times the whole thing. So here's example 3. We need to find x, y, and z. So we're going to have to write three different, you're going to use the corollary 3 different times for the 3 pieces. So I have x here that I need to find, and I have y here and z here. I'm going to start with the x. So I have the 6 which is my altitude, so that's going to be 6 squared, is going to equal the x times the 9. And if I divide both sides by 9, I end up getting x equal to 4. Now I'm going to use the shorter leg. So the shorter leg is equal to, or the shorter leg squared, I should say, so y squared is equal to that same shorter side times the whole thing. Now we already found out that x is 4. So y is going to be equal to 4 times, and then the whole thing here is going to be the 9 plus the 4. So that's 13. And that's what I'm going to put here. So again, the shorter leg is the shorter piece of the hypotenuse times the entire thing. So y squared is going to be equal to 4 times 13, which gives me 52. Then I have to take the square root of both sides. So I have y squared equal to 52. Take the square root of both sides. These two cancel each other out. I end up getting y equals the square root of 52, or if you simplify that, that ends up being 2 root 13, which was y. The very last one, we need to find z. Z is the longer leg of the hypotenuse, so z squared, or excuse me, the longer leg of the triangle, is equal to the longer piece of the hypotenuse times the whole thing, so 9 times 13. Again, if I multiply both of those out, I end up getting 117. So I have z squared equals 117. Square root both sides, I get z equals square root of 117, or if you simplify that, that gives you 3 root 13. So now we found our x, y, and z. Again, to practice this on your own, I need you to go to page 521, problems number 11 and 13, and then you can check your answers in the back of the book. Helpful hint, once you found the unknown side lengths, you can always use the Pythagorean theorem to check your answers. And you guys are very good at Pythagorean theorem. You did a whole lot of that last year. Last question, same thing as example number 3, only now it's a word problem. So we have to estimate the height of the Douglas fir, the height of the tree. Jan positions herself so that her eyes sight to the top and bottom, and the tree to the angle is, to the ground is 90 degrees, so from her eyesight to the tree. Her eyes are about 1.6 meters above the ground. So that's this length here, 1.6. And she's standing 7.8 meters from the tree. So this distance from her eyes to the tree. What is the height of the tree to the nearest meter? So we're going to have to set up the same proportion. We have this altitude for these triangles. So this altitude is 7.8. That number squared, 7.8 squared, is going to be equal to the shorter piece of the hypotenuse times the longer piece of the hypotenuse. I don't know what this one is, so I'm going to mark that as x. That's 1.6 times x, and then we're going to divide both sides by 1.6. This is a 1. I end up getting x equal, and then it's 38.025 if you either do that longhand or stick it in the calculator. So x is about 38, what are we talking about, feet? Meters. About 38 meters. Now they didn't ask us to find x, they asked us to find the height of the tree. So I have the 38 plus the 1.6. And that's going to give me 39.6 meters for the height of the Douglas fir. At the end of this lesson, you should be able to answer all of these questions. If you can't answer one of the questions, or if the questions, go back and view the video, and or write your questions or anything that you don't understand at the bottom of your notes so that we can talk about it on Monday.